Resolution of vectors is the transformation of vectors into its vertical and horizontal components. Let's take an example. Let's transform this vector with a velocity of 10 meters per second at an angle of 30 degrees above the horizontal into its vertical and its horizontal component. So this will be your vertical component, which is, let's say, Vy, and this is horizontal component Vx. So we can make this into a triangle, into a right triangle. So this will become your Vy, and this is your Vx. This is your 10 meters per second at an angle of 30 degrees. If we remember our trigonometry, SOHCAHTOA, if this is your angle, this is your opposite, and this is the hypotenuse. So the ratio we need is sine. So sine of 30 degrees is opposite over hypotenuse 10 meters per second. So to remove 10 meters per second, we need to multiply both sides by 10 meters per second. 10 meters per second. So this will cancel out, leaving only Vy. So 10 meters per second times sine of 30. Sine of 30 is 0.5. So Vy is equal to 10 meters per second times 0.5 is 5 meters per second. So this is your vertical component. Now we solve for the horizontal component. From what we can see in the triangle, if this is your angle, this is the angle adjacent, this is the side adjacent to the angle, and this is still your hypotenuse. So adjacent over hypotenuse is cosine. So let's say cosine of 30 is equal to adjacent Vx over hypotenuse 10 meters per second. So to remove this, we multiply both sides by 10 meters per second. This is 10 meters per second. So this will cancel out, leaving only Vx. 10 meters per second times cosine of 30. Cosine of 30 is 0.866. So your Vx is 10 times 8.866 is 8.66 meters per second. So this is your horizontal component. The resultant is the vector sum of two or more vectors. It is a single vector that is equivalent to two vectors that is usually a vertical and horizontal vector. Let's take an example. We have a vertical vector of 5 meters per second and a horizontal vector at 8.66 meters per second. So we want to find a resultant vector, a single vector that will represent these two, which is equivalent to these two. So let's say this will be your resultant vector. So this is your V, which you don't know yet. And we need to find the angle that it will form. So since this is the height, we can move it to the other side and we can transform it into a right triangle. So let's say this is your Vy at 5 meters per second, and then this is your Vx at 8.66 meters per second. So we need to find this V. Now this is a right triangle, so we can use the Pythagorean theorem to solve for V. So V is equal to the square root of this one and this one. So 8.66 squared plus 5 squared. So this will be 8.66 times 8.66 is, rounding up, is 75. 5 times 5 is 25. So this is your V. So your V is the square root of 75 plus 25, or 100. Your V is equal to 10 meters per second. Now to get the angle of this, we will use trigonometry. So katawa, this is opposite, this is adjacent, so the function that we need is tangent. So tangent theta is equal to opposite Vy over adjacent Vx. So tangent theta is equal to 5 over 8.66. So the units will cancel out. So what we have left is 5 divided by 8.66 is 0.577. So this is your tangent theta. So if we're looking for the angle, we get the inverse function of this one. So we write it as tangent to the negative 1 of 0.577. So this is equal to 30 degrees. So this is your angle, and this is your vector.